My name is Leif. I am 34 years old. And I'm a data science lead here at Elkjøp Nordic. Prior to that, I've been working in the computer games industry for quite some years. And then I had a little stint in banking and finance before I joined Elkjøp. But I have pretty much been working in software development and technology, I guess, for the last maybe 12 years or so. Well, so I started in the games industry as a QA tester. So it's more about ensuring that the engine, the technology, and the content was up to standards and not full of bugs, basically. Because of my background in graphics, I started working with the rendering team, the graphics programmers. And eventually I got more and more into software development practices, methodology, and more of the human aspects of software development, more of the soft parts of software development, the human parts of software development, collaboration between different experts, within different domains, artists and programmers, designers and engineers, kind of in between those roles. Most of the software projects I've been a part of in the past have had some degree of kind of data-driven features, if you will. Even in the games industry, it's there's a lot of production of data, but like content for the actual games. But there is also a lot of data that is used to improve the gameplay, for example. So I only worked on massively multiplayer online games. So we would, for example, have data mining to see how the players would move around in the different play fields, and then we could use that data to improve the gaming experience. I didn't get into, I guess, what you would call maybe data science until Elkjøp. Here at Elkjøp, we want to provide the customers with the best possible experience, basically, and provide them with the products they want, the products they need at the best possible price point. So it's a brick and mortar retailer with also a very strong online presence. So it's more very much a omni-channel retail setting, online, offline, where we try to erase the borders between the offline shopping experience and the online shopping experience. So to do retail well, there are many different domains kind of that go into that, like everything from finding the products that customers want, that customers need, acquiring those products, and then warehousing them, distributing them to all of the stores. So there's a lot of logistics involved. And there are a lot of planning aspects, strategic and tactical aspects regarding stores, for example, staffing of stores, shift planning things, the operations kind of the business. But also there's a lot of stuff on the more strategic and planning level. So there are many different domains, business domains, where data could be applied in various ways. We start with the business requirements, and then we will brainstorm that and try to define the problem, so to speak, or define the need, and then afterwards the solution to that problem or to that need. sometimes that involves creating our own machine learning models or our own systems. Sometimes it might be really just to help improve the human work process, or the solution is not always technical. It's very often it's like a way of working kind of thing, a process kind of thing. So the role of a data scientist here is to basically use data to deliver business value in some way, but also to advise kind of on alternative solutions, not necessarily just jump right into developing something ourselves, But we have a large number of content providers who basically provide us with product information. Like suppliers will have, by suppliers I mean the companies that produce the actual products that we sell, that we buy from. The products that they create, they have certain attributes, and we need to get all of that product data into our own systems internally, so that we are able to sell those products and provide the customer with compare functionality online or many different things. But there are a large number of these products, so it's not feasible for humans to do this by themselves, to categorize and clean the product data and make sure that this product attribute from the supplier equals this product attribute inside of our internal structure. So we have provided the people who are doing this with machine learning based tools that help automate parts of this process to make that easier. Store managers to staff our stores according to the expected number of customers, number of orders in each particular store, for example. Five or six different models in production. Some of them are neural network models. Some of them are not. Basically, simpler models. Some of them are tools for human beings to help them ease their workflow. Some of them are more like system components with APIs that are integrated with other systems within the organization to kind of add some value. Sometimes it's just a matter of using capabilities that already exist within systems that we have in our environment. So that might be I don't know, some component of some system. A lot of the third-party systems that we license, that we use, they have built-in machine learning models, etc. already. And we see more and more of them are getting these smart capabilities because, of course, these software vendors are also on the machine learning train and using that to improve their products. So we indirectly benefit from that. So in those situations, we just need to make use of whatever is already there, and maybe we need to communicate with the vendors to kind of make that happen. In some cases, we might need to go and buy a new solution, a system, if that makes sense. Economically, I mean, if that's the most reasonable thing for a given problem, we will do that. And then if neither of those situations exist, we might choose to build something ourselves, and then we have done that internally, and also with external consultants as needed. Right now it's very small. It's 2 people.
Oh, okay.
It's only me and one other guy, my colleague. So I mean, one of the main challenges within data science is also kind of There's so many exciting opportunities out there, and there are a lot of good offers for data scientists. Having a long-term stable team is quite difficult in a sense. I guess it would have to be communication between more technical people and non-technical people, the collaborative effort of understanding the business, the domain knowledge within a given domain, like say logistics, for example, or I don't know, some other finance or some other department, and understanding that to a sufficient enough, having good enough understanding that